In this presentation, what we are going to do is test this data set to see if there's any box plot outliers. Okay, so simple enough exercise. It's related to box plots and specifically is there any outliers according to the method you use to detect outliers when constructing box plots. Essentially what we're going to do is first off calculate the lower fence, okay, then the upper fence, and we're just going to test it very quickly to see if there's any potential outliers in this data set. Okay, we're not drawing the box plot or anything like that. So the key things we need are, let's get rid of that. The key things we need are, I'll just change this to black, is first off the Q1, the lower quartile, Q3, the upper quartile, and finally the interquartile range, which I'll just write up here, IQR. That is Q3 minus Q1. Okay. Now, so essentially what we do here is we have 30 observations, and what we're going to do, and they're sorted, they're in order. So what we're going to do is partition the data set up into two halves, the lower half and the upper half. Okay, so there's 15 in the lower half, 15 in the upper half. Okay, now what the Q1 is the median of the lower half, so it's there's 15 items. The median is the middle item, so it's the 8th item of the lower 15. So it's this value here, 856. Likewise, the Q3 is the median of the upper half, and that is the 8th item of the upper half. So 1, 2, 3, 4, 5, 6, 7, 8. So it's 929. Okay. Now there's various different ways of calculating the Q1 and Q3. I'll just go for the simplest one there. So this is 929. Now the interquartile range is Q3 minus Q1, and that is 929 minus 856. Just working that out very simply, it is 73. Okay, so we have everything we need. Let's go back to the lower fence. The lower fence is Q1 minus 1.5 times the interquartile range. Okay, the upper fence is Q3 plus 1.5 times, plus now in that case, plus 1.5 times the interquartile range. Okay, so I'm just going to start on a new page here, so that I have more room. So the lower fence is 856 plus 1.5 times 73, and I just need, there we go. So the lower fence is 856 minus 1.5 times 73, okay. Working that out on the calculator, we will get 856 minus 1.5 times 73. Just bear with me a second. I'll confirm that calculation. 109.5. Okay. So the lower fence would be 746.5. Okay. The upper fence is very similar. That is 929 plus 1.5 times 73. That is 929 plus 109.5. That is 1038.5. Now, so these are our two important values, the lower fence there and the upper fence there. Essentially what we're going to do is just check back to our data set and see, are there any values less than the lower fence? And here the lowest value is 807. No, there's no values less than the lower fence. And what about the upper fence? Is there any values there greater than 1038.5? No. So in this particular case, we will not have any outliers on our box plot. Okay, that's it really. So that's just a sort of just as a remark. This is not really about drawing the box plot, but I'll just sort of state how we might draw that there. In this particular case, the lowest value is the lowest value, not a box plot, so this is going to be 807. And we draw our interquartile range here. Okay, And the highest value that's not a outlier is the upper whisker. So those where we would draw the whiskers. Okay. Just say for argument's sake, 807 was an outlier, we would draw it like this, and the next lowest value would be where we draw our box plot there. That's just a sort of, it's not really the point of this exercise, but it is how we would, that's just to sort of confirm, if you're not unfamiliar with this stuff, what would happen if we did find an outlier. You draw it as a little dot or a little asterisk, and then suppose 807 was an outlier, the lowest value not an outlier, let's suppose that is 811, that's where you would draw the whisker for your box plot. Okay, so that's box plot outliers.